Hello students, today we will do chemical bonding and molecular structure question part 6. Disclaimer, the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in the deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. So what we are going to do basically today, we are going to practice question from 1 to 7. Question number 1. Question number 1 says that which of the following statements is oblique are true? Options are A. HF is less polar than HBr. B. Absolutely pure water does not contain any iron. C. Chemical bond formation takes place when forces of attraction overcome the forces of repulsion. And D. In covalency, transfer of electrons takes place. So you have 10 seconds to solve this question. Your time starts now. Okay, let us see how we can solve it. So we have to check that which statement is correct. So basically, if you solve the question, then the correct answer would be C, that a chemical bond is formed when force of attraction are greater than the force of repulsion, right? So whenever two atoms come together, tend to make the chemical bond, there is a equilibrium between the force of attraction and the force of repulsion. Okay. So whenever these atoms comes close, initially the only the force of attraction comes into play. But as they come closer and closer, force of repulsion also comes. Okay, and then our equilibrium point is chosen such that we have a minimum repulsion and a maximum attraction. Okay, and then only a chemical bond is formed. Question number 2. Question number 2 says that consider the Born-Haber cycle for the formation of ionic compound given below and identify the compound form. We are getting from M solid to del H1, M gaseous and del H2, and then we get as M plus gaseous. Similarly, if we start from half X to gaseous, we get delta H3 gives us X gaseous and delta H4 gives us X minus gaseous. Now we combine both of this to get Z. We have to identify the Z. So the options are A, M plus X minus solid, B, M plus X minus solid. Sorry, this is M plus X minus. This is M plus X minus solid. This is Mx and this is M plus X minus gaseous. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see how we can solve it. So first of all, this is a question of Born-Haber cycle, and we are starting from the initial state of metal and say X2 both, and then we are in the first step we are converting them into gaseous atom and then into the required anions. So the correct answer would be B. So it takes place in two steps as follows. Okay, so this is the way we can do it. So we are since we are going from M gaseous to we're starting from the M salt, we are moving to the M plus gaseous. Okay, so M salt, then M gaseous, then M plus gaseous. Similarly, half X2, then X gaseous, then X minus gaseous. Now they both will combine, and the energy that will be say emitted will be equal to lattice enthalpy, and your compound will be M plus X minus solid. Okay. Now this Z is M plus X minus solid. So this is for question 2. Now moving on to the next question. Question number 3. Question number 3 says that what is the geometry of nitrogen atom in NH3, NCH3 whole thrice and NSiCH3 whole thrice? Molecules. 1. Trigonal planar. 2. Triangular pyramidal. 3. Square planar. And you have to choose the correct option. Your options are A. 2, 2 and 1. B. 3, 3 and 1. C. 1, 2 and 3. And D. 1, 3 and 2. So you have 10 seconds to solve this question. Your time starts now. Okay. Now let us see the solution. So we have to see that what is the geometry of nitrogen atom in these three compounds. First we have ammonia, second we have trimethylamine, and third we have silicon substituted. Okay, this is trimethyl silicate, which is TMS. So this is not trimethyl. This is not silicate. Okay, so this is trimethyl. There are the three methyl group attached to each SIs. So the correct answer is A first of all. So in case of NH3 and NCH3 whole 3, the triangular pyramidal shape is seen because of the lone pair bond pair repulsion. Okay, so this is the thing for the NH3 and CH3 whole 3. Triangular pyramidal, where N is at the top of the pyramid and all the three H's are in the say at the vertices, at the bottom vertices. Same is the case for this the trimethyl substituted amine and ammonia. Now, if you move to this NSiCH3 whole thrice, then we will find that it is planar in nature. So this is a very interesting phenomena, where your nitrogen lone pair is being donated to the vacant d orbital of the silicon. Okay, so we have a lone pair, and that is responsible for the repulsion and for the construction of this pyramidal shape. Now, when this lone pair are no more available and they are being donated to the silicon, that results in a absence of lone pair and reduction in the lone pair bond pair repulsion. Okay. Now, where are they donated? So they are donated in the d orbital of the silicon, and that results in p pi d pi bonding. So p pi from the nitrogen and d pi from the silicon. Clear? Okay. Now that will result in one less steric number, and hence it will not be say triangular pyramidal anymore. Instead, it will be what? It will be triangular planar. Okay. Now moving on to the next question. So this is basically our thing. So we are triangular pyramidal and this is triangular planar almost. So if you talk about question number 4, question number 4 says that O2 molecule is paramagnetic due to the presence of, options are, 2 unpaired electrons in anti-bonding molecular orbital, 1 unpaired electron in anti-bonding molecular orbital, 2 unpaired electron in bonding molecular orbital, and 1 unpaired electron in bonding molecular orbital. So you have 10 seconds to solve this question. Your time starts now. Okay, let us see how we can solve it. So we have to see that why it is paramagnetic. So those who have solved, the correct answer is A. So for a thing to be paramagnetic, it should have a unpaired electron. Okay, what it should have? It should have an unpaired electron. So this is the electronic configuration of O2. You can see that there is pairing of each of the electron. There is 1s2, sigma star 2s2, sigma 2s2, sigma star 2s2, sigma 2pz2, super sigma 2px2, sigma 2py2, and sigma 2px1. So this is your unshared pair. Okay, this is your unshared pair of electrons that we have. Now, according to molecular orbital theory, there are 2 unpaired electrons present in anti-bonding molecular orbital, hence it is paramagnetic. So paramagnetic are something which is attracted by the magnets. So since it has what? It has a unpaired electron in the sigma star 2px of each of this. Therefore, it will be paramagnetic. Moving on to the next question. Question number 5. In BCl3, the BCl3 is a planar molecule while NCl3 is a pyramidal shape. Why? Options are A, BCl bond is more polar than NCl bond. Option B, NCl bond is more covalent than BCl bond. Option C, nitrogen atom is smaller than boron atom. And option D, BCl3 has no lone pair electron, but NCl3 has one lone pair electron. So you have 10 seconds to solve this question. Your time starts now. Okay, let us see how we can solve it. So we have to see that why is BCl3 pyramidal shape, planar shape, and why NCl3 is pyramidal shape. So for those who have solved, the correct answer is D. So as there is no lone pair on the boron of this BCl3, so this will be the structure. Okay, triangle planar. You can see it very clearly. Where there, on the other hand, there is one lone pair on nitrogen that will result in the what? That will result in the pyramidal shape, which is this. Okay, so you consider this part. This is your pyramidal shape. Okay. Overall, it is what? Overall, it is tetrahedral, but since it is forming a pyramid, so it is a pyramidal shape. Clear? Okay, moving on to the next question. Question number 6. Question number 6 says that H2O is a dipolar, okay, whereas BeF2 is not. It is because the electronegativity of fluorine is greater than that of oxygen. H2O involves hydrogen bonding, whereas BeF2 is angular discrete molecule. Option C, H2O is linear, BeF2 is angular. Option D, H2O is angular and BeF2 is linear. Okay, so you have 10 seconds to solve this question. Your time starts now. Okay, let us see how we can solve it. So the question says that H2O is dipolar, whereas BeF2 is not. We have to find the reason for that. The correct answer is D. So if you look at the structure of H2O, it is angular V shape and has sp3 hybridization and a bond angle of 104.5. Now its dipole moment is value is positive and more than 0, therefore mu is greater than 0. Okay. So this is the thing, it is been mentioned here also. But if you talk about the BeF2, the structure is linear. Okay, because mu is equals to 0 in this case. This is due to mu is equals to greater than 0. Thus, due to mu greater than 0, H2O is dipolar. And due to mu equals to 0, BeF2 is what? It is non-polar. So it is all due to the presence of the lone pair of the electron on the what? On the water. Moving on to the last question. Question number 7. So this is basically your BeF2. You can see it very clearly, and this is your H2. Question number 7. Question number 7 says that in terms of polar character, which one of the following order is correct? Your options are A, NH3, H2O, HF, H2S, B, H2S, NH4, and H2O, HF, C, H2O, NH3, H2S, HF, and D, HF, H2O, NH3, H2S. So you have 10 seconds to solve this question. Your time starts now. Okay, let us see how we can solve it. In terms of polar character, we have to see that which one of the is correct. So the correct answer is B. So polarity is decided by how? It is decided by the electronegativity difference between two adjacent atoms. Now the correct order for the polarity is H2S first of all, then NH3, then H2O, then HF. Okay, so this is the correct polarity order. Okay, so this was all for today's session. Thank you.